Hello everyone, myself Swati. I'm here with my teammates Sausanya and Pujita. Our capstone is automated adversarial red teaming for LLM safety. The goal is a practical, reproducible pipeline that proactively probes LLM for unsafe behavior and produces clear auditable reports. Next slide. This slide represents the agenda of our presentation. We start with introduction. Next, we go with related works, proposed work, which will spend most of the time. Then data set and differences. We will end by taking feedback with Q&A slide. Next slide. LLMs can still be jailbroken or coaxed into unsafe outputs, despite alignment's efforts. Our goal is to build a collab-friendly red teaming pipeline that generates adversarial prompts, evaluates model responses, and triages results into actionable reports. Our objectives are: one, automate adversarial prompt generation and testing. Second is score and filter outputs with a reward model, and give engineers a clean UI plus report to review findings. Our deliverables are a modular Python project, a static UI we can show today, and exportable reports and logs. Next slide. Next, related works. Prior work shows that RLHF and safety fine-tuning reduction, but do not eliminate jailbreaks. Community datasets and benchmarks catalog risks areas like toxicity, illegal guidance, or self-harm. An emerging direction is automating red teaming agents that iteratively craft prompts and run programmatic evaluations across target models. Next slide. Later works. We see gaps that we can address in a capstone settings. Reproducibility. On student hardware and collab, many tools assume paid infra, limited UI visibility for auditing results, inconsistent taxonomies of harm types, weak iteration hygiene, randomization, logging, and error handling often get skipped. Our proposal focuses on programmatic solutions to those gaps. Next slide. At a high level, we run a C-driven loop. The loop will be like this: C database to red model to target model to reward model, and then triages and report. There is a data layer for seeds and validation subset. Models for adversarial prompt generation, the target to be probed, and a reward model for scoring. Next is orchestration via simple app. Later, storage reports will be JSON-L and HTML. My friend Sausanya will take you through architecture details and static UI we are presenting today.
Thank you, Swati. Now coming to the architecture details um, of our project, and so we our design is modular and configuration driven, so we can swap the model backends if we need, and also the path without any code changes. This loops, the loop logs every step for auditability. And uh, coming to the architecture details, like we lean on configuration first, so which is YAML or JSON for model choices, thresholds, and paths. So sampling uses a fixed RNG seed where needed, with options for true random and stratified selection by harm type. And coming to the prompting, we do have strategy layers where we use free shot and role play templates to elicit stronger unsafe attempts within ethical guidelines. And coming to the reward model, it scores toxicity or harm and gets what's accepted, flagged, or skipped. Thresholds can also be tunable. And finally, we also add resilience, like which is like the timeouts, retries, graceful fallbacks for model or API errors. And now coming to the UI and reporting works. So a static UI is backend agnostic, like the components read mock JSON, and later we switch to Flask endpoints via fetch. And pages we are showing gonna be like the console, the review, export, and the metrics. And coming to the design principles, it's clean, readable keyboard accessible and clearly labeled where it's not yet wired to backend. So, and also the review, the shows the table, seed ID, risk area, prompt, response, and score, by also giving the choice for the users to apply the filters for risk area, score, threshold, and jailbreak flag, which I'm going to show you later in the presentation. And a detail drawer reveals the full text and taxonomy tags. And coming to the exports and metrics, it includes stub generate report, and we are also going to give the download zip buttons for the users, and also plus cards and placeholder charts for harmful jailbreak rate or per risk breakdown. And coming to the current progress, so far we have thoroughly worked on bootstrapping our data from the Libra AI and the do not answer data set, which usually have the 939 rows. That's our basically our seed database. And we also created a 100 item validation subset, and then we also standardized the local paths or configs for collab drive, and we scaffolded routes and the full static UI experience. And we also completed an end-to-end smoke test with the mock data. So now I'll be showing you like the real progress of what we have done now. Yeah, this was our progress till the last week. So here you can see this was the recent this was the major iteration we have run. So you can see the table shows the iteration, seed ID, risk category, toxicity level, and success, as I've discussed in the previous slides, and also the metrics we have used for um, the evaluation purpose. And here you can see the model selects any random random prompt in the seed database, and that's the risk category of, this is the category level, where we have the collection of categories already present in the database. And the model gives itself the toxicity level of what kind of category it is. And this is like the success, which has two flags, whether it can be 0 or 1, depending if the red model successfully have probed the target model, we get 1 based on it. If it fail, we it's like if it failed to probe the break the target model, so then it's gonna be 0. And we can also see the toxicity probability and also toxicity score. And the model starts by taking the prompt, um, and then creating an adversarial prompt for it. The fine tuning the prompt even more. So you can see the more the pro I mean here you can see like the adversarial prompt created by the red model, and this is the response of the target model. Yeah, this is our response of the target model. And then the scores of the and the evaluation metrics of the particular prompts. And this is for all the iterations. It shows any, there is no particular interactions for this page. So we have come up with adding more features to our HTML. So UI, which is like the current one. This is our recent iterations we have run so far by after modifying the UI code. So here you can see the total number of rows, like how many rows and the iterations. Here we have run we have given the model to go for 2 iterations. So the total number of rows selected here is like the 20, and there are also filters we have applied like as we presented. So we can select, we can search for any specific prompt here, and we can also apply any kind of, I mean, we can select the iterations, and then we can also have the feasibility to select the risk type, and also based on the success flags here. So here it shows the proper, like as I said, the iteration seed adversarial prompt, and the response of the target model, and also it shows the success flag as well, and also the probability of toxicity. And we are still changing and adding more changes to it. And then we are also going to represent everything using perform analytics here, uh, using charts. And um, that's what we have done till now. And then, so coming to the, let me go back to the presentation. So coming to the known issues and the fixed plan, what's left, the seed selection sometimes looked non-random, as I mentioned that the prompts are generated randomly. So sometimes they look non-random. We'll fix this by using the RNG usage and add stratified RAS. And coming to the adversarial prompts, we find occasionally weak or empty prompts, so we are adding few short and role play templates with guardrails. And overscored toxicity on the benign text, so we calibrate thresholds and include human spot checks. UI lags and export glitches when wired, we use timeouts, retries, and keep exports as separate simple step. So coming slides will be discussed by Pujita.
Coming to the data set, our primary seeds come from the library or do not answer data set. It has 939 prompts to cover diverse risk areas. We maintain a 100 item validation subset for fast iteration and sanity checks. We also support local JSON seeds so we can add course appropriate examples. As we refine prompts, we will add road based templates and scenario variants per harm category. Next slide. These are the differences from the paper we chose. Uh, Coming to the first one, collab first reproducibility. Like no special infrastructure is required, configs drives everything. And coming to the modular backends, we can swap red target or reward models via config only. And coming to the auditable UI and reports, static UI now, Flask later, clear reviews and exportable artifacts for grading and replication. And coming to the taxonomy, aware sampling and evaluation, uh, it has strong iteration hygiene and randomization, logging, timeouts, and it has the zip export of all artifacts. Next slide. Coming to the risk and mitigations, uh, we use lightweight models, bats or catching and resume for collab compute limits, and for model API instability, we have configurable backends, local fallbacks, retires with backoff. And coming to the reward miscalibration, it has human spot checks, threshold tuning, multiple scoring signals. And next slide. Coming to the conclusion, we build a practical, audible red teaming pipeline for tailoring course setting. And in the next sprint, we focus on prompting templates, sampling, calibration, and UI polish. We would love to hear your feedback on evaluation metrics, thresholds, and any additional risk categories we should include. And thank you.